So I don't know how many of you followed the news in ethical machine learning, but there was an article this week by a publication called ProPublica, and they produce investigative journalism. They took a look at some zip codes in Illinois, and they found that certain zip codes were paying more for the same car insurance premiums. So they were paying more money, even though all of the different risks were the same. And what they found were these zip codes also reflected racial biases, and that black neighborhoods were paying more than white neighborhoods. This is just one example of the many ways that our algorithms and models can possibly reflect biases that we don't intend for them to do. So today we're going to talk about creating fair models even when we have an unjust world. I don't know how many fans we have of Black Mirror. How many people have seen Black Mirror? And how many people have seen this particular episode? Excellent. For those of us that haven't, Black Mirror is a science fiction kind of fantasy world, and it often talks about the horror between technology and our lives. This is from season 2, and it's an episode called Nosedive. And in this world, we see Lacey here, and she's the main character. In this world, everybody is based on ratings. So essentially, your whole life is a metric. Other people rate you when they interact with you. It's 5 stars or 1 star, anything in between. And those ratings help determine where you can live, where you can work, what you can do, and who you interact with. In the episode, we have Chester here. He and his partner broke up, and his partner convinced everybody to downvote him. Eventually, his rating gets so low, he cannot go to work anymore. And this is kind of course, a very dystopian picture, and you might be like, Katharine, what does this have to do with anything? But when we think about all of the ways that we connect, we follow, and we like different things in our world, and the signals that sends the algorithms that then further recommend things to us, that further tell us who we should connect with, then we are actually making these statements. And these statements may or may not affect not only what we see and who we can connect with, but also affect the other people on the receiving end. So just like Chester could not get in the door, where are the doors in our society? And by this, I don't mean physical doors. I mean metaphorical or symbolic doors. One such example could be our career path. So job applications often have algorithms behind them, or at least some sort of metric that you must meet to move forward. LinkedIn, of course, uses suggestions and recommendation systems to determine who we should connect with and who is maybe most similar to us. And common networking, both in person and online, follows our social circles. How we deal with money and how we're evaluated with money also is affected by these doors. Whether we can get a small business loan or a home loan is often based on some sort of metric. We're evaluated and determined whether we are credit worthy. Peer-to-peer lending usually uses these social network circles to determine what type of people we might want to lend to or be recipients of. Universities and our schooling, how we find out about new career opportunities to grow and learn more, are also affected by these algorithms. And often these university applications, for example, go down to a series of metrics based on standardized test scores. And finally, social media, dating sites even, and the recommendation algorithms that feed us the news that we read and what we decide to like on whatever social network we are on, all of those take into account these signals that we send. Whether the signal is, I'm going to ignore this person, I'm going to swipe right, whatever it is, those signals are things that feed algorithms that determine what we see. And as many studies have shown in the past year, those can even affect elections. So depending on what news we have and the so-called bubbles that we're in, then we can get into this feedback loop where we're surrounded by people who think like us. So when we live in a world that is very unjust, Nawal el-Saadawi, a famous feminist and radical from Egypt, tells us that we must be dissidents. And when I see this quote, I wonder, what does it actually mean to be a dissident here? Can't I just do my work? Can't I just be a data scientist and I'm a good person, I'm trying to do the right thing? Isn't that enough? And I think that she would advise us that perhaps we can take it one step further. That just being a good person doesn't necessarily mean that we're pushing things forward, that we're really challenging the industry to do things potentially differently. I would hope that by the end of this talk, we can maybe agree that there are certain steps that we can take so that we're more accountable and moving forward with ethical machine learning. Finally, there was an article a few months ago by Mike Montero, and he called it "Ethics Cannot Be a Side Hustle." He was writing towards a design audience, and he used the Uber Greyball application. How many people here have heard of Uber Greyball? So it's this application, and it's served to what they call flagged riders. These are usually people that are government inspectors. They're people that are trying to crack down on Uber, that Uber is illegal wherever the jurisdiction is, and they're trying to find the riders and the drivers as well. So they developed this application called Greyball that serves them a fake app experience. They look like they're using Uber, but they're not. And Mike's argument was that you cannot build something as unethical as this during the work week, and then on the weekends buy your ethical offsets by donating your time to social good. I would agree with this sentiment. I think that most everybody in this room has data skills and could probably find a job tomorrow if you wanted to. So if you're asked to do something unethical at work, or if you feel like you might be working for an unethical company, then I put the onus on you to make the decision to make a move and make a statement by putting your work behind somebody you can believe in. So how do these things come to happen? We have this world, our world has injustices, and then all of a sudden they're in our algorithms. So I'm going to take you through a bit of a story. I believe that with most stories around data science, it starts with the data itself. So we are in this world of quote unquote big data. Whether you believe it or not, it is around us. And particularly if you do machine learning, you've probably been exposed to the idea that larger data sets generally generalize better, that they are more useful, and that particularly if you're doing neural networks or deep learning, that you benefit from having the extra data, that your model learns better and is better applied to real-world situations, or perhaps data that it hasn't seen before. So if this big data is great for us, then what might be lurking underneath? Crowdsourced data has been really revolutionary, especially in some of the NLP tasks, when we're able to use crowdsourced data for things like sentiment analysis or even image captioning. Then we can see much better results because we have a lot of different data and different perspectives about the same image or the same tweet and so forth. So crowdsourcing has been really pushing the envelope forward and when it comes to certain NLP tasks. This is an image from the Flickr 30K dataset. And a PhD student here in Amsterdam, Emil van Miltenburg, sorry if I pronounced that wrong, he's a student at the VU Amsterdam, and he took a look at this Flickr 30K dataset. And he was able to find both gender and racial stereotypes lurking in the captions. One of the top-rated captions of this image is, "A worker is being scolded by her boss in a stern lecture." We can see that the automatic assumption of this image is that the woman is the worker and the man is her boss. We can also see that the automatic assumption is that she has done something wrong and is being reprimanded. Another caption for it is, "A hot blonde girl getting criticized by her boss." So if we needed even more encoding, we can see that women will be categorized by their physical features, and the man is again assumed to be her boss. What he found even beyond this is that anybody in the dataset who looked even particularly Asian was immediately classified as Japanese or Chinese. And anybody who looked dark-skinned was immediately classified as African American, even if there was no signal in the photo that they were in America or that the person was American. So we can see that these sneak into our data sets. We need crowdsourcing because it helps us give those larger data sets and it helps us achieve things with these NLP tasks. But at the same time, Emil points out in a further article that perhaps we are training our models not only to view the world from an American mindset, but possibly also a white American mindset. I think that another thing that we need to think about in regards to our data is whether it was sourced ethically. Now, if you're the type of person that would ethically source your clothing or ethically source your food, then why would you not ethically source your data? I think that one unfortunate part of this is we do not have a good way to be conscious consumers of data. A lot of times, the way that it was collected and how it was collected is somewhat obscure for us. So the more that we can push to have the data provenance, to have the way that it was collected, to have the information about how these customers consented to their data being shared, the more that we can determine whether it was ethically sourced and really push on having that data be collected the proper way. I would argue that data privacy has become a privilege in our world, that it's no longer a right, and that because of the way that we've capitalized data, that it reflects some of the forms of capitalism in our world. One of the ways that this is done is by offering free services in exchange for data use. So, for example, Facebook will offer free Wi-Fi if you check in. They do so that they can collect the check-in data and then use the check-in data to sell advertisements. Now, how many other forms are similar to this? And how many other surveys or chance to win also do this same collection of data? Too often we are kind of collecting data at the behest of whoever the end user is, rather than thinking about the actual customer or the client that we're collecting the data from. And within our data sets, we're not asking often how exactly they were collected. Also, another privilege is technological literacy. So within this room, we're fairly technologically literate. We're aware of being able to use VPNs and Tor and using incognito sessions and so forth to protect our data browsing history. We are also aware when we see weird forms online, perhaps to back away and not fill them out. This is one example from Formismo, and it essentially is an opt-out form. And what they did when they did studies on this is something between 60 and 70% of people would just click the default options. So they would never uncheck boxes or check extra boxes. So when data is collected this way, or perhaps even survey data is collected this way, we have to ask ourselves, does the end consumer actually know that their data might be sold to third parties? Do they know that their data might be used for some other purpose? When they're browsing around online and they don't remember to delete their cookies, do they know that they're getting a different price? Do they know that their data is being collected and used to serve them different advertisements? I would say that the average internet user probably doesn't know these things, and that perhaps we should think about how to better signal for them. Thankfully, the EU has put in some great data privacy regulations, but they're constantly being challenged in the courts. And sometimes our data comes from outside the EU, so we need to be cognizant when we make those decisions. Andreas Duves gave a great talk at 32C3, the Chaos Computer Club conference. And what he was able to show, and he released his Python code, I'll have links to all of these things in a post at the end. But what he was able to show with the linear SVM is that the more data that he gave to the model, the better it was able to discriminate amongst groups. He had created some artificial data that had certain differential characteristics between two different groups. And the more data he fed it, the better it was able to discriminate. Now that's great for us as data scientists in the sense of, hey, it's learning and it's doing well with discrimination, right? If that's the task that we're looking for, then we're doing quite well. But what we have to ask as ethical data scientists is to take a step back and say, how much data do we actually need? And how much accuracy do we actually need? Is it always better to use more data and have higher accuracy, even if the data that we're using is perhaps less ethically sourced, or perhaps adding in some of these unintended correlations? So often we find that these data sources find their way into our models. If we're doing our job right, then our models reflect the real world. And if they reflect the real world and the real world has injustices, then our models therefore reflect these real injustices. Now, that might be fine depending on what you're doing. Whatever you're doing might have very little impact or just be used internally. But we have to really think about, does that bleed into other areas, and does this impact people's lives and livelihoods? One easy way to see if the biases are coming through is by looking at natural language, because we can look at language and we can make interpretations on the meaning of the words or the phrases. And one great way to do that within data science is to use word vectors. So there was a great study by Eileen Kaliskan-Islam, along with two really prominent ethical machine learning specialists, Joanna Bryson and Arvind Narayanan, and they did a study on word vectors. They used GLOVE, but I feel like you could easily do with Word2Vec and it would give you the same results. And what they were able to show is that language inherits these cultural biases. And they did so in numerous ways, but one of the ways that was really prominent was the ways that gender was reflected in profession. That often the jobs that were more gendered towards women were easily, you could see the shift of the word vector to correlate women with the female-centered jobs and men with the male-centered jobs. So one really easy way to show this is to simply use Google Translate. In Google Translate, you can take a gendered language, like English or German or whatever you would like, and you can translate into a non-gendered language. Turkish is a non-gendered language. So we can take a phrase, she's a professor and he's a babysitter, and we can put them from English into Turkish. When we click simply to reverse translate, all of a sudden he becomes the professor and she is the babysitter. And this is, again, Google is not doing anything evil. The Translate app is not written by a bunch of sexist monsters. This is simply in the word vectors themselves. The word vectors have learned these relationships. They've done what we asked them to do. They learned the fact that in our data that we feed it, it has these biases. We know that more men are professors and more women are babysitters. And so these language biases come through in the data. They're learned in the language, in the way that we talk about it, and then they pop up in Google Translate. Another great example and data set that I was impressed by how quickly it could turn an inequality into a metric was the ProPublica study on COMPAS. Now, COMPAS is a recidivism risk evaluation system. And what it does is it attempts to guess how likely it is that you'll go back to jail or prison once you've been let out of jail or prison. So it's used in several jurisdictions within the United States to determine, along with other metrics, whether a person should be left out on early parole and so forth. The ProPublica study said this machine learning algorithm, this software is racially biased. And they showed this chart, which is a distribution chart. And on the left, there's the different scores for the Black defendants. Going from the left to the right, it goes to the increased risk. And from the white defendant scores, they are on the right-hand side, and you can see that there's a majority distribution towards the lower decile scores. However, Abe Gong, a data scientist in San Francisco, took another look at the data. And he took instead a look at the conditional effects. And here, sorry, the font is a bit low, is a bit small, but the probability of recidivism is on the y-axis, and then the scores are along the x-axis. And what we can actually see here is the dots are fairly close together. So the algorithm or the software in and of itself is not biased. In fact, we see that some of the blue dots, which represent the white population, actually have lower probability for a higher score. Now, what does this tell us? How can we see a distribution like before and yet still see that the algorithm in and of itself is in fact skewing probability towards in favor of the black offenders? What it tells us is maybe this metric is not so much measuring recidivism, but instead is measuring the policing tactics of certain officers in the United States. And if the policing tactic is that I am more likely to pursue, arrest, and really challenge a black defendant versus a white defendant, then this can explain what's happening. So I think that we like metrics, we like numbers, they make sense, they measure things for us, and I think often they're useful. But if we forget what the metric is actually measuring, then it's really easy to get confused and to just kind of fall asleep at the wheel and let the numbers and metrics take hold of our algorithms. So if it's really easy to have these type of insidious things in our data, and then it's really easy for that data to learn them and display them in algorithms, then how can we actually test for this unfair treatment? How do we test for what I would sometimes refer to as embedded isms? This is different sexism, racism, homophobia, transphobia, other things like that in our models. If we can't test for them, then we probably don't know that they're there. And if we don't test for them, then they're likely there and we're just ignoring them. One way that this can be tested is by looking at disparate impact. And what disparate impact looks at is it looks at two different groups and a particular outcome. So let's say Smurfs and non-Smurfs, and they are going for loans, and they would like to get the loans. Now we can determine disparate impact if we can show the probability of a Smurf getting a loan is very higher than a probability of a non-Smurf getting a loan. And if we can show that it's above a certain delta, then we can say, yes, this has a disparate impact. This is overly affecting the non-Smurfs, and they are being treated unfairly. This is used in several court cases, but it also is a great measurement just within our own data sets to determine. Again, this, however, requires kind of almost a binary outcome, and not every problem has a binary outcome. One such example is using word embeddings. So again, Eileen Kaliskin and her co-researchers developed two different tests to test word embeddings. They're called the Word Embedding Association Test and the Word Embedding Factual Association Test. And it essentially is based on a psychological study. And this psychological study allows you to correlate words with one another. And it measures the correlation by how quickly you're able to correlate and raise your hand or press a button to say, yes, that relates to that. This test usually starts out with easy things like flowers are pleasant and insects are unpleasant. I would argue with that. I quite like insects, but this is a test that works fairly well in psychology. What they did to model it amongst their word vectors is they took cosine similarity, and then they took the probability of that cosine similarity over all of the different vectors. And they were able to show some interesting and also quite icky relationships within the vectors that they trained. For example, in the German word vectors, they were able to find pleasant or positive relationships between German nationality words and the German vectors, and unpleasant relationships between Turkish nationality words and the German word vectors. So this is great if you're dealing with word vector data. I highly encourage you to take a read of the paper and perhaps apply some of the tests yourself. So if you're not dealing with NLP data and you're not dealing and you're not dealing with a binary outcome situation, how do you determine that there's unfairness in your data set? Well, another great paper, and also a Python library that you can install, is called FairTest. And what FairTest tried to measure is unwarranted associations in the data. So a lot of times we can find that gender or race is encoded in other features. So maybe gender is also encoded in first name, or maybe race is also encoded in zip code or possibly last name. And when we start to take a look at the way that the model starts to correlate these two things, and even if we remove the variables that we don't want it to learn, and it still determines that these signals are happening in other parts of our data, FairTest is a great way to try and find these relationships. And they have both ways that you can take a look at particular features. Again, this is for tagged features. But they also have ways that you can have it run discovery and try to find some features for you that may be correlated to the variables that you would like not to have inserted into your data set. So if we can test and we can find that we have unfair treatment, or perhaps we are already running something in production and we find that there is this unfair treatment, how can we figure out how to combat this unfair treatment? How can we remove it without sacrificing our models, right? We still want great models. We still want good predictions or suggestions or classifications and so forth. So how can we use these broken data sets and broken models to a certain degree and fix them ethically while still having good accuracy and so forth? One possible way, which was presented by Evan Astola, who's a lead machine learning researcher at meetup.com, is to use ensemble models. He gave a great talk at Machine Learning Seattle, I believe, called When Recommendation Systems Go Bad. And what he and the Meetup team noticed is their recommendation algorithm had learned how to correlate gender with interest, and was doing things like suggesting more technology meetups to men than women, because it had learned more men attend technology meetups than women. What they didn't want is this reinforcing the status quo of the industry. And so what they decided to do is to segregate their data, to have one model that is aware of gender, along with a few other data sets, to have another model that's aware of interests. And therefore, the models were not able to have these unwanted learning associations. Then they use an ensemble model at the end, and they get the benefits of all of the different data sets, but the models themselves are unaware of the other data connections. Perhaps another way to fight it is to take a look, and this is again with somewhat of a binary outcome situation, at equal odds and equal opportunity. So there was a great paper that was released near the end of last year called Equality of Opportunity in Supervised Learning. I highly recommend taking a read, and they also released an interactive that you can play with and see online. And I'll read just a few excerpts from the paper because I feel like they are quite important. Equalized odds enforces that the accuracy is equally high in all demographics, punishing models that perform well only on the majority. So this is essentially asking us to pin our true positive and true negative rates for our models across different demographic groups. That's kind of a high task. So they also released a possible relaxation, which they called equal opportunity. So this possible relaxation of equalized odds is to require non-discrimination only within the advantaged outcome group. That is to require that people who pay back their loan have an equal opportunity of getting the loan in the first place. So this is instead pinning only the true positive rates to one another. But one thing that this helps protect against is just that our model performs well for the majority use case. And often that's what We do. But when we take a look at how it might affect minority groups within our data set or different demographic groups, then using this equal opportunity helps us ensure that we're treating people fairly, or at least more fairly than assuming everybody conforms to the majority group. Finally, we need to create transparent and explainable models. This was a constant refrain across nearly all of my research, that the less we're able to introspect and explain our models, the less we're able to figure out what they've learned. And if they've learned something that we don't want them to learn and we can't see or explain them, then it's unlikely that we can then combat them. I was having a great discussion with my PyData Berlin co-organizer, Matty Lyra, and he's an NLP doctorate. And we were discussing the dangers of the fact that we're seeing more and more of these machine learning as a service providers come around. And I think that that's really great. I don't think that you should have to have a machine learning expert to do machine learning. But the danger I feel like that we border in those moments is that the end user, do they actually know what's happening in the model? Do they actually know what they're using machine learning for? Do they know what data they should keep out? Or do they know if their data is perhaps acting unethically? This is a really big problem. And if you work at a startup that does machine learning as a service, you need to really think about how you communicate to the end user what is happening. There was a great article on building more clear and explainable models called Ideas on Interpreting Machine Learning. It was by the H2O AI team. One of the examples out of many that they gave, again, I highly recommend reading it, is the idea of using maximum activation analysis to take a look at your neural network. What this allows you to do, and we've seen this a lot in the computer vision, is kind of inspect what nodes are learning what attributes. So we've seen this a lot in computer vision, or perhaps all of this style transfer. Oh, this node is learning this particular part of face recognition, or this node is learning this particular part of Van Gogh's style, and so forth. But when we have non-visual data, how do we inspect? One way to do so is to build and generate fake data that can show us the maximum activation. If we build this fake data and we notice that some of the nodes are starting to learn attributes that we don't want it to learn, then we can figure out perhaps how to downweight or remove those activations. So perhaps here we have the real customer and we have the bad guy, and we see they're activating different nodes. And then we may notice over time that there is some overlap between our real customers and the bad guy, even though they don't represent what we want the model to learn. So I hate to put ethics and Wall Street in the same sentence. So I really considered taking this out, but I think it really is great. So even though ethics and Wall Street don't normally go together, Emmanuel Derman and Paul Wilmot are two financial modelers, researchers, and authors around kind of the quant space, so to speak. And after the financial crisis of 2008, they took a step back and they wrote this thing they called the Financial Modelers Manifesto. And it's kind of like the Communist Manifesto for financial modelers. And even though not all of us work in quants or with financial products, I still think that we can take a lot from this manifesto. It is indeed what they called a Hippocratic oath for modelers. And I do think that there's something to be said for having an ethical creed for us as data scientists and as machine learning experts, so to speak, or implementers at least. So I'll go through it and we can see how much of it applies to our work. I will remember that I didn't make the world and it doesn't satisfy my equations. Though I will use models boldly to estimate value, I will not be overly impressed by mathematics. I will never sacrifice reality for elegance without explaining why I have done so. Nor will I give people who use my model false comfort about its accuracy, Instead, I will make explicit its assumptions and oversights. And finally, I understand that my work may have enormous effects on society and the economy, many of them beyond my comprehension. Again, I don't think every one of these applies to all of the work that we do, but I do think the idea of humility, the idea of clarity, the idea of indifference to fancy math and doing things the most clever way is perhaps something that we can take away. And maybe we can use something like this creed as a starting point for creating a more ethical way to do machine learning and data science in the projects and the work that we do already today. So I want to end with a quote by another pretty awesome lady. This is Rosalind Franklin, who helped discover DNA. And she said that science and everyday life cannot and should not be separated. What I think that she means and what I take away from this is that they're inherently intertwined, right? A lot of the work that we do, we get the data from everyday life, and we're building products and trying to affect change also in everyday life. So we can't pull them apart. And if the everyday life of our world reflects injustice, then our models, of course, do so too. What I challenge us to do is to not be a feedback loop that is spouting more inequalities and more injustice into the world. That this feedback loop is already here, but that I challenge us to actually try to put less inequality in the world and build more fair and more equitable models than already exist. If we take into account that we apply some of the things that I've covered in this talk, and we build and continue to challenge more things that allow us to create ethical or more ethical machine learning products, then I think that our models can actually help fight injustice in the world, and that we can be a dissident, as Nawal El-Saadawi would call us. So I challenge you not to just be great data scientists and great machine learning specialists. I challenge you to be great and ethical machine learning specialists and data scientists. And I think that we as a community can do so. We can do better. Thanks.